Question 11. A particle P moves in a straight line and passes through a fixed point O. Okay, imagine you have a particle P. It's going to move in a straight line. It will pass a fixed point O. Displacement is equal to S. It's given by from 0 to 3 is this one, and from 3 to K it's going to be this one. Given that for 3 to K, which is this timeline, the velocity is positive. Here V will be positive and acceleration is negative. Here acceleration will be negative. The maximum velocity of P is when t is equal to 2. If this is velocity time graph, the highest point of velocity will be equal to 2. This is max. On the axis below, sketch a velocity time graph for the first k second of the motion P. Okay, before we start, let's do some quick revision. This is chapter 14, calculus. You need to be able to apply differentiation and integration to kinematic problem. Okay, so in kinematic, you have displacement, velocity, and you have acceleration. If they give you displacement and you want to find velocity, we will need to differentiate displacement over time. If they give us velocity and we want to find acceleration, we need to differentiate velocity. And if you want to go backward, if they give you acceleration and you want to find velocity, you need to integrate acceleration. And if they give you velocity, you want to find displacement, you integrate displacement. Now, they give us displacement, which is this one, and we need to use displacement to build velocity graph. So, from displacement to velocity, we need to differentiate S. Another thing that you need to know about this relationship, if we have a graph of velocity time graph, the slope over here, which is m, the acceleration, the area under the graph is going to be the distance. The main topic here is kinematic with calculus. You need to know how to use piecewise function in motion. Piecewise function means different piece of a function that join together. We have two different sets of equation based on its time. Let's differentiate the first one. When it's a 0, t3, displacement is s equal to, differentiate this, ds over dt, that would be, this is power 1, 1 bring in front is just 1 times t, but 1 minus 1, this is 0. Anything power 0 is equal to 1. So 1 plus, again power rule, 2 bring in front, 2 times 6, t 2 minus 1, this one will be 12, t power 1. Again power rule, 3 bring in front, minus 1, that would be, let's do for the second one, which is 3 to k. Our 3 to k is this equation. Now let's do the same for differentiation of ds over dt. Again, this one, power 1 bring in front, 12t differentiate is just 12. Differentiate 2 bring in front is going to be negative 2. 1 over 3, t 2 minus 1. So it's just going to be negative 2 over 3, t. Any constant will be equal to 0. Now, so let's divide this graph into 0, and we have displacement, velocity, and acceleration. For acceleration, 0, 12, negative 60. And for this part, our acceleration will be 0 and just negative 2 over 3. Let's sketch our graph for V. First 0 to 3 seconds, so probably 3 is somewhere over here. Our velocity is in a quadratic form. It's ax squared plus bx plus c. A is negative 3, so negative 3 t squared plus 12t plus 1. We know that if it's negative a, our graph will be a sad face graph with a maximum value of v over here. Okay, it's gonna look something like this. So at t equal to 0, let's find what is our v. T is equal to 0, our v will be, substitute 0 here and here, so our v will be equal to 1. If v is a concave downward, this one will be the maximum point. Okay, where maximum point is a, it's going to be equal to 0 because there's no gradient here. Sub a equal to 0 to find our t. 12 minus 60, 12, t will be 12 divided by 6, t 2. Okay, let's plot our graph. If t is 0, v is 1, this is 1. That is our starting point of a set face. Okay, so set face with a maximum v, that is 2. 2. Now, we want to know how high is this. Okay, they also mentioned that at t equal to 2, it's a maximum velocity, so it's confirmed that that is the highest point of our concave graph. Now, if we want to know what is the value for v at time is equal to 2, let's substitute that. So, at t is equal to 2, our v 1 plus 12, put 2 here, minus 3 power 2. This one, 13. My highest point over here will be 13, like that. And we know it's going to be concave downward at 3. So I'm just going to put 3 here. And I'm going to draw the first graph. Okay. Now we finished the first part of this one. Let's do the second part. We want to plot v. And from this pattern, we know that it's straight line graph, which is y equal to mx plus c, where our m is going to be negative 2 over 3 plus 12. 12 is where it cuts at here. This is negative gradient. We know that it's going to look something like this. Let's find what is v when t is equal to 3. T is equal to 3. My v will be, so I'm not going to use this anymore. I'm going to use this. So I will substitute 3 here. 3 is cancelled, so it's just going to be 12 minus 2, and that is 10. My v is 10, which is 10 point at 3. I'm going to extend this a bit. So now, I'm just going to draw one straight line like that. This is where it cuts at y is equal to 12. Okay, that's it. This is the marking scheme. The first mark is when we find v by knowing that we need to differentiate the displacement. This is our answer. That is 1 mark. Time is 3 to k, which is this part right here. That is 1 mark. Our graph shape like this. It start go down at 3. So it start go down at 3. Okay, so let's move it a bit in front. Okay, go down at 3. So go down at 3 and then straight line. 2 marks for the graph. So 4 marks there.